Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over probability and likelihood of events. So whether events are likely to happen or unlikely to happen. So let's first talk about several definitions up here. The first one here is an experiment is an activity involving chance. So every time that you're playing maybe a board game, well, if you're rolling a dice in the board game, well, there's a probability of rolling certain numbers. And are you going to roll the number you need? Maybe if you're playing a game, if you've ever heard of aggravation, well, to get out of your home spot, you have to get a 1 or a 6. So you have 2 possible numbers out of 6 numbers that you could roll. That's an experiment that you're doing, rolling that dice to try and get what you want. So each repetition or observation of the experiment, so each time that you roll that dice and see what number you get, that's what we call a trial. Every single possible result is what we call outcomes. So when we roll that dice, we could get a 1, a 2, 3, 4, 5, or 6. And then the last thing here is called a sample space. This is when we have a list. When it says set here, it's a list of every single possible outcome. So I just listed the sample space for rolling a dice when I listed out 1 through 6. So sample space is every single possible outcome in that experiment that we're doing. So here are several examples. We actually did this rolling a number cube or a dice. So the sample space, every single possible outcome would be 1, 2, 3, 4, 5, 6. So those are all possible outcomes. Flipping a coin. So when you flip that coin up in the air, think about what possible outcomes could you get? Well, you're probably thinking heads or tails. And you're going to see that sample space is often used by abbreviations so that we don't have to write those all out. Sometimes you will see it, though, as listed out as heads or tails. And then last one, spinning this spinner in a game. So what are the possible outcomes? Well, I know it's hard to read there. The first one, we could get red in that upper left-hand corner. We could get yellow, blue, or green. And if you wanted to, you could abbreviate these as well, R, Y, B, and G. Okay? Now, next vocabulary term, we have an event. So I'm going to be often talking about events because we're going to get into multiple compound probability where we're doing more than one thing. So maybe in the game you have to spin a spinner and roll a dice. Each of those are what we call events. So is an outcome or a set of outcomes in an experiment. And then after that, we're going to find probability. So probability is the measure of how likely an event is to occur. All right, now how we find probability, I'm going to come off to the side here and I want you to write down this definition. We see probability as a capital P, and then it's written as a ratio, so a fraction. The top number we find by looking at favorable outcomes. So if I'm trying to find the probability of rolling a 1 or a 6 on that dice, well, how many 1s and 6s are on the dice? Well, there's 1 1 and 1 6, so there's 2 favorable outcomes. That would be the top number. And then the bottom number is the total number of outcomes. So when we roll that dice, well, we could get 1 through 6, so there are 6 total possible outcomes. That would be the bottom number, okay? So over here, let's highlight this part. This is how we're going to find probability of certain events. Now, after we do that, probabilities can be written many different ways. Most likely, we're going to be writing them as start as fractions, because that's how we just set up our definition there of probability. Well, we can divide those fractions and we can turn them into decimals. And then also we could take those decimals and here, let's say the decimals are going to be anywhere from 0 to 1. So if you ever get 1 point something as a decimal from that fraction, we know we've done something wrong. And then lastly, we could take those decimals and we could also change them to percent. So you've probably heard of, a 50-50 chance, a 50% chance of something happening. So percentages will be 0 to 100%. okay? Now, let's talk about the likeliness of events happening. So the closer that the probability is to 1 or 100%, so 1 it would be as a decimal, 100 as a percent, the more likely it is to occur. So if you look down here, that is all this space, so from about 50% to let's say 99%, so 51% to 100%. That is what we call likely events. All right, the closer that the probability is to, and I'm going to change my color to match these, to 0 or 0%, then the less likely it is to happen. So everything from about 1% to 49%, all of that is what we call then unlikely. And I will ask you this after we find the probability of certain events. I may say, what's the likeliness of that event to happen? So over here, there's different ways to describe our likeliness. So as likely to occur as not. So this would be right in the middle. This is our 50%. So that is as likely as not, meaning we have the same exact chance of it happening as not happening. Okay, less likely, we talked about that one. So that is from 1 to 49%. More likely, so likeliness would be 51 to 99. And then there's two other words. So impossible means that it's never ever going to happen. So that is going to be a 0% chance. So maybe rolling a 7 on the dice. Well, that's not possible. There is no 7. So we just say it's impossible. And then the other one is certain. That means it is 100% going to happen. So let's say rolling a number on a dice. Well, they're all numbers. We're not going to get a shape or something else on a dice, as long as it's a normal dice. So that would be a certain event, 100%. Okay? So if something is extremely likely, does that mean that it's impossible? So extremely, sorry, I read that wrong. Unlikely. So extremely unlikely doesn't mean that it's impossible. Not necessarily. There's still a small chance that it is possible to happen. It's just extremely unlikely. The favor is not in yours. So maybe an example of this would be something like winning the lottery. The chances of winning the lottery is very, very slim. It's unlikely. However, it does happen. It is still possible. Okay? If something is extremely likely, so that means it's very, very possible that it's going to happen, does that mean that it's certain? Does it mean that it's 100%? Not necessarily. I thought about last week when we got a snowstorm. I thought, well, what's the likeliness of us having school tomorrow? It was pretty likely with a snowstorm in April, but was there a chance that something happened and we didn't have school? Yeah, absolutely. So extremely likely that we're going to have school tomorrow, but we'd never know. Something could happen, and there is a small chance that maybe we don't have school tomorrow, but most likely we are going to have school tomorrow. So those are some examples of events that are extremely unlikely or likely, but it's still possible that they happen. All right, let's go to the next page, and we're going to start categorizing events into either certain or impossible, as equally likely as not, right in the middle, or likely or unlikely. So if we look at the event, and we could actually think of the probabilities. So there will be 24 hours in the day. So if we think of the probability of this, well, how many of these 24 hours, we're looking for favorable, so how many 24 hours in the day are 24? Well, that's all of them. Out of a total of how many hours? 24. Well, 24 over 24 is 1. This is 100% chance of happening. There is every single day going to be 24 hours in the day, so that's a certain event. Okay? Correctly guessing a number between 1 and 1,000. So think about this. You're thinking of one specific number. So the probability of this happening is 1 out of a total of 1,000 numbers. So 1 out of 1,000, that's going to be a pretty small percentage. It's very unlikely. All right, a coin lands heads up. So heads, there's 1 head on the coin out of 2 possible outcomes, heads or tails. So 1/2 is our 50% or our 0.5. So this is one of those that it's as equally likely as not. Equally likely as not. It's right in the middle. All right, Cecilia rolls a 10 on a standard number cube. So we talked about this, a dice, how many 10s are on a dice? Well, there's no 10 on there out of 6 possible numbers. So 0 out of 6, it's gonna simplify to 0. This is impossible. We can't roll a 10 on a number cube. Okay, I'm gonna pause there because I want you to get some examples and try them on your own. So try those out, those last few examples. And then down here, you're gonna be putting them on a number line. So we looked at that number line on the last page, and our goal here is to figure out the probability. So flipping heads on a coin, we actually found that up above. So we said there was 1 head on that coin out of 2 possible outcomes. So heads or tails. And then 1/2 simplifies to 0.5. So right here in the middle of our number line at 1/2, that is where our event would go. All right. And we could draw arrows. Let's do that. So this will go right here on our number line. Rolling a 6 on a number cube. So how many of these, and I'm going to show you actually how you are going to see this. You're going to see capital P and then parentheses what we're trying to find. So rolling a 6 on a number cube. Well, how many 6s are there? There's 1 out of 6 possible outcomes. So if we divide those numbers out to a decimal or a percent, so we could do 1 divided by 6. We get 0.1666, so on. It looks like it repeats. So our decimal version would be 0.16666, so on, so on, so on. So if we change this to a percent, well, move your decimal twice. Percents are out of 100. So it'd be 16.6, and I'm going to round up to 0.7. So 16.7%. So we know this is going to be between 0 and 50%. So, and remember right in the middle of 50, so this is about 25%. So if we were putting this on the number line, and here are some helpful percentages, this would maybe go right in here. So this is a unlikely event. Okay? Again, keep working on those, and we'll talk about and go over some of those answers in class.